Solutions. Dravanalu. This is the very simple chapter with a beautiful applications in our daily life. What is a solution? The homogeneous mixture of two or more components is called as a solution. రెండు లేదా అంతకన్నా ఎక్కువ పదార్థాలు కలిసిపోయి ఏర్పడే సజాతీయ మిశ్రమాన్ని ద్రావణం అని అంటారు. ద్రావణాలలో ఉండేటువంటి రెండు అనుఘటకాలు కనుక ఉన్నట్లయితే వాటిని ద్వి అనుక ద్రావణాలు binary solutions అంటారు. If there are two components, then we can call them as binary solution. In our intermediate stage, we have binary solutions. We can concentrate on them only. The two components present in that, they are called as solute and solvent. For example, if you take water and you add some salt, కొద్దిగా నీరు తీసుకున్న సాల్ట్ కలిపి మనం స్టర్ చేసినట్లయితే కలిపినట్లయితే that will be dissolved completely. In this, salt has taken less quantity, తక్కువ పరిమాణంలో సాల్ట్ తీసుకున్నాం కాబట్టి దాన్ని మనము ద్రావితము లేదా సొల్యూట్ అని అంటాం. సొల్యూట్. దిస్ ఇస్ ద్రావణి, solvent. So how can we define them? The component which is dissolving in another component is called as solute. The component which dissolves some other component is called as solvent. And scientifically we can call them like this. The component which is less in quantity is called as solute. The component which is more in quantity is called as solvent. Based upon the nature of the solute and solvent, these are classified into gaseous solutions, liquid solutions, and solid solutions. There are different examples are there. And as the concentration of the solute, that means the quantity of the solute increases, the concentration is increased. So, to express the concentration, there are several terms are there. They are molarity, normality, molality, mole fraction, weight percentage, mass percentage, volume percentage, mass by volume percentage, some other methods also there. So if you see the mass percentage, the mass of solute by the total mass of the solution is called as mass percentage. If you see the volume percentage, the volume of the solute and the total volume of the, that means the ratio of the volume of solute and volume of entire solution is called as volume percentage. Mass by volume means the mass of solute is divided by the volume of the solution can be called as mass by volume percentage. And ppm, parts per minute, million, ppm, parts per million. So the number of parts of solute divided by total number of solution, total number of particles in solution into 10 to the power of 6 will give us the ppm. And coming to molarity, number of moles of solute by 1 liter solution is called as what? This is the N by V. You know very well, number of moles is equal to what? Weight by molecular weight, liter. And this can be written as W2 by M2 into 1000 by V in ml. And normality means number of equivalent weights or number of gram equivalent weight present in 1 liter solution is called as what? Normality. So this is what? Number of gram equivalent weights by volume. So the gram equivalent weight will be given as weight by equivalent weight into 1000 by B. And this equivalent weight of substances is calculated in different manner as the different nature of the substance. For acids, we can get the equivalent weight by dividing their molecular weights by their respective basicity. And if you see the equivalent weight of bases, that is given by molecular weight divided by what? Acidity. Like that, we can calculate. And in the case of oxidant or reductant, we have to take their molecular weights or formula weights, which is divided by number of electrons which are transferred in the reaction. And if you observe this molarity and normality, they are dependent upon the volume. But volume may vary with respect to the temperature. So therefore, not to change the concentration with respect to temperature, the another term has come, that is what? Molality, M. This is capital M. This is capital N. This is small m. Molarity means number of moles of solute present in 1 kg of solvent is called as molality. Here the weight of solvent is given. So therefore, this is what number of moles of solute divided by, this is N2 also we can write, number of moles of solute divided by weight of solvent in kilograms. This can be written as weight by molecular weight into 1000 by W1 in grams. And here mole fraction. Mole fraction means here the ratio of number of moles of one component to the total number of moles of components present in the solution can be called as mole fraction. For example, N1 moles of solute is present in N2 moles of solute is present in the solution, and let the number of moles of solvent is N1. Then mole fraction generally denoted by small x or capital X. Always you remember in the chapter of solutions, 1 is for solvent, 2 for solute. So this is x1 is equal to n1 by n1 plus n2. x2 is equals to n2 by n1 plus n2. Right? This is about this one. So మనము 1 లీటర్ ద్రావణంలో కలిగి ఉన్న ద్రావిత మోల్ల సంఖ్యను మొలారిటీ అని అంటాం. 1 లీటర్ ద్రావణంలో కలిగి ఉన్న ద్రావితం యొక్క గ్రామ్ తుల్యాంకారాలను నార్మాలిటీ అని అంటాం. ఈ తుల్యాంక భారాలను నిర్ణయించడానికి వేర్వేరు పదార్థాలకు వేర్వేరు రకాలుగా ఉంటాయి. యాసిడ్స్ తీసుకున్నట్లయితే, ఆమ్లాలు తీసుకున్నట్లయితే వాటి యొక్క అనుభారాలను క్షారత్వం చేత భాగించినట్లయితే ఆమ్లాల యొక్క తుల్య భారాలు తెలుసుకోవచ్చు. అదేవిధంగా క్షారాల తుల్య భారం తెలుసుకుంటే క్షారాల యొక్క ఫార్ములా వెయిట్ ని లేదా అనుభారాలను ఆమ్లత్వం చే భాగించినట్లయితే క్షారాల యొక్క తుల్య భారాలు వస్తాయి. క్షయకరణి మరియు ఆక్షీకరణ యొక్క తుల్య భారాలు తెలుసుకోవడానికి వాటి యొక్క అనుభారాలు లేదా ఫార్ములా భారాలను నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ చే భాగించినట్లయితే వాటి యొక్క తుల్యాంక భారాలు వస్తాయి. తర్వాత మొలారిటీ మరియు నార్మాలిటీని మనం పరిశీలించినట్లయితే ఆ రెండు కూడా ఘనపరిమాణం పైన ఆధారపడి క్యాలిక్యులేట్ చేస్తాం. ఈ ఘనపరిమాణాలు క్యాలిక్యులేట్ చేసినప్పుడు ఘనపరిమాణం ఎల్లప్పుడూ కూడా ఉష్ణోగ్రతపై ఆధారపడి ఉంటుంది. అలా ఉష్ణోగ్రత మారినప్పుడు ఘన పరిమాణం మారుతుంది కాబట్టి ఏం చేస్తామంటే ఈ అడ్వాన్స్డ్ గా మొలాలిటీ తీసుకుంటాం. హియర్ ఇన్ ద మొలాలిటీ మనం ఏం చేస్తామంటే ఒక కేజీ ద్రావణిలో కరిగి ఉన్న ద్రావిత మోల్ల సంఖ్యని మొలాలిటీ అని అంటాం. దిస్ ఇస్ డినోటెడ్ బై స్మాల్ m, మొలాలిటీ ఇస్ డినోటెడ్ బై క్యాపిటల్ M. దిస్ ఇస్ గివెన్ బై దిస్ ఈక్వేషన్. తర్వాత మోల్ ఫ్రాక్షన్, మోల్ భాగం. మోల్ భాగం అంటే ఏంటంటే ఒక ద్రావణంలోని ఒక అనుఘటకం యొక్క మోల్ల సంఖ్యకు ద్రావణంలో ఉండే అనుఘటకాలన్నింటి మోల్ సంఖ్యల మొత్తానికి గల నిష్పత్తిని మనము మోల్ ఫ్రాక్షన్ లేదా మోల్ భాగం అని అంటాం. సో ఒక ద్రావణంలో N1 మోల్ల ద్రావణి, N2 మోల్ల ద్రావితం ఉన్నట్లయితే ద్రావణి యొక్క మోల్ భాగాన్ని x వద్ద సూచిస్తాం. దట్ ఈస్ గివెన్ బై N1 by N1 plus N2. సో x2 is equal to ఏమవుతుంది, N2 by N1 plus N2 అవుతుంది. ఈ విధంగా మనం మోల్ ఫ్రాక్షన్ తెలుసుకోవచ్చు. తర్వాత ఈ ద్రావణంలోని ద్రావితము గనుక వాయు స్థితిలో ఉన్నట్లయితే దాని యొక్క ద్రావణీయతను తెలుసుకోవడానికి హెన్రీ నియమం మనకు ఉపయోగపడుతుంది. హెన్రీ నియమం ప్రకారంగా వాయు స్థితిలో ఉండే ద్రావితం కనుక మనం ద్రావణిలో కరిగించినట్లయితే ఆ ద్రావితం యొక్క బాష్ప పీడనము ద్రావణములో దాని యొక్క మోల్ భాగానికి అనులోమానుపాతంలో ఉంటుంది అని హెన్రీ చెప్తాడు. దట్ ఈస్ పార్షియల్ ప్రెషర్, దట్ ఈస్ partial vapor pressure of a solute is directly proportional to mole fraction of the gas in the solution is called as Henry's law. This is the partial pressure, the partial vapor pressure of a solute is directly proportional to the mole fraction. So this P is equal to some constant KHX, where KH is called as Henry's law constant. So if we plot y is equal to mx. M is the slope. This is like straight line which is passing through the origin. So y is what? Pressure. X is what? Mole fraction of the gas in the solution. This is known as what? Henry's law. Now, if you see and if you come to the Raoult's law. So Raoult's law is nothing but this is also similar to Henry's law. And simple method we can say that the relative lowering of vapor pressure is equal to the what? Mole fraction of the solute. And this Raoult's law is applicable for only dilute solutions in which non-volatile solute is dissolved. అంటే అబాష్పశీలి ద్రావితాన్ని కరిగించి ఏర్పడిన ఒక విలీన ద్రావణంలో సాపేక్ష బాష్ప పీడన నిమ్నత ద్రావితం యొక్క మోల్ భాగానికి సమానంగా ఉంటుంది. Now we can see that this relative lowering of vapor pressure is equals to mole fraction of the. What is relative lowering of vapor pressure? This is a colligative property, Kanadhara dharmam. Colligative property ante Kanadhara dharmam ante the properties depend only on the number of particles of solute are called as colligative properties. If you see the colligative properties, relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Here, now we can say, if we take and if you dissolve one solute in a solvent, and before dissolution or before solubility, before giving, ante ద్రావితాన్ని ద్రావణిలో కలపక ముందు ద్రావణి యొక్క బాష్ప పీడనము P10 అనుకున్నట్లయితే ద్రావణం యొక్క బాష్ప పీడనము P1 అనుకున్నట్లయితే always P10 is greater than P1. So therefore, P1 naught minus P1 is called as lowering of vapor pressure. P1 naught minus P1 is called as lowering of vapor pressure. బాష్పపీడన నిమ్నత. సో ఇప్పుడు దీన్ని మనము P1 naught minus P1 ని P1 naught చే భాగించినట్లయితే we can get relative lowering of vapor pressure. Relative lowering of vapor pressure. ఈ రకంగా మనకు సాపేక్ష బాష్పపీడన వస్తుంది. సో దిస్ ఈజ్ ఈక్వల్స్ టు వాట్? x2. So therefore, from this concept, what can we say here? P1 naught minus P1 by P1 naught is equals to x2, means n2 by n1 plus n2. This is a dilute solution. So for the dilute solutions, n2 is less than n1 and hence n2 is far less than n1. Therefore, we can write it as P1 naught minus P1 by P1 naught is equal to, simply we can write it as n2 by n1. That is, we can write like this. N2 means what? Number of moles of solute. ద్రావితం యొక్క మోల్ల సంఖ్య. N1 is equal to ద్రావణి యొక్క మోల్ల సంఖ్య. So therefore we can write it as P1 naught minus P1 divided by P1 naught is equals to N2. N2 means W2 by M2 into M1 by W1. So from this equation, we can calculate the molar mass of a known solute. సో ఈ రకంగా రౌల్ట్ నియమం ఆధారంగా చేసుకుని వచ్చినటువంటి రిలేటివ్ లోయరింగ్ ఆఫ్ వేపర్ ప్రెషర్ పరిశీలించినట్లయితే we can get the molar mass of a known solute which is dissolved in the solution. Okay, this is about what relative lowering of vapor pressure. And we can come to the colligative properties. One is relative lowering of vapor pressure. Here, the properties which depend only on the number of particles of solute are called as colligative properties. They are relative lowering of vapor pressure, సాపేక్ష బాష్పపీడన నిమ్నత, ఇందాక మనం చెప్పుకున్నాం. నెక్స్ట్, ఎలివేషన్ ఇన్ బాయిలింగ్ పాయింట్, బాష్పీభవన స్థాన ఉన్నతి. డిప్రెషన్ ఇన్ ఫ్రీజింగ్ పాయింట్, ఘనీభవన స్థాన నిమ్నత. ఆస్మాటిక్ ప్రెషర్, ద్రవాభిసరణ పీడనం. సో హియర్ వేపర్ ప్రెషర్ అంటే ఏంటి? The pressure exerted on the surface of the solution where there exists an equilibrium between the solid particles and dissolved particles in a solution. Here, for example, if we take, initially we have only solvent. So here we have taken one liquid and kept one lid. If we don't use this lid, ఒకవేళ మూత పెట్టకపోయినట్లయితే ఆ ద్రావణాన్ని బాష్పీభవనం చెందుతుంది. కొన్ని రోజుల తర్వాత దాని యొక్క లిమిట్, దాని యొక్క లెవెల్ తగ్గిపోతుంది. But if we keep some liquid, that is, if we keep one lid on that one, the level will be like that only for some time. Here, then there are these particles have been experiencing some attraction forces from different sides. ఈ ద్రావణి కణాలు అన్ని వైపుల నుండి సమానంగా ఒక రకమైన బలానికి లోనవుతాయి. సో ఎప్పుడైతే ఈ ఉపరితలం పైన ఉన్నటువంటి కణాలు ఇక్కడికి వచ్చినప్పుడు అవి బాష్పీభవనం చెందడానికి అవకాశంగా ఉంటుంది. సో ద పార్టికల్స్ మే బి వాట్? వేపరైజ్డ్. And similarly, at the same time, same number of vapor particles or gas particles, they will be converted into liquid. And the conversion of the gas particles into liquid is called as liquefaction. And the conversion of liquid into gas is called as vaporization or evaporation. Here, if we see this one, now I have added, one second. Here, before addition of the solute, here the pressure exerted by this vapor on the surface is called as vapor pressure. Right? Here, by the addition of this one, what solute? That is which type of solute? Non-volatile solute. By the addition of non-volatile solution, well, by the addition of non-volatile solute, the number of particles present on the surface is decreased. So therefore, the number of particles which are evaporated is reduced. So therefore, the pressure exerted on this one by this vapor will be reduced. So therefore, what can I say? Always P1 is greater than P1 naught is greater than P1. So that is P1 naught minus P1 by P1 naught is called as relative lowering of vapor pressure. Just now we have seen, discussed. And elevation in boiling point. Actually, what is the boiling point? Simple, the temperature at which the liquid boils. Now, how can we say here? The temperature at which the liquid state of the substance and the vapor state of the substance are in equilibrium is called as boiling point. ఏ ఉష్ణోగ్రత వద్దనైతే ఒక పదార్థం యొక్క ద్రవ స్థితి మరియు బాష్ప స్థితి ఈక్విలిబ్రియం లో ఉంటాయో ఆ టెంపరేచర్ ని బాయిలింగ్ పాయింట్ అని అంటారు. Here, this is what to equate the vapor pressure of the solution. So we need much and more heat. That's why the boiling point of solution is always greater than that of the solvent. Now, what can we say here? This is TB naught and TB. This is the boiling point of pure solvent, boiling point of solution. Here, TB naught is less than TB. That is, TB is greater than TB naught. ద్రావణం యొక్క బాష్పీభవన స్థానము ద్రావణి కంటే ఎక్కువగా ఉంటుంది. So this is given by delta TB is equals to TB minus TB. And delta TB is directly proportional to M. What is this M? Molality. So therefore, delta TB is equal to some constant Kb into M. This Kb is called as molar elevation constant or ebullioscopic constant or molar boiling point constant. Here this is. Now, here this can be written as delta TB is equals to Kb. What is a molality? Molality means weight by molecular weight of solute into 1000 by what's weight of solvent. So, from this equation, we can calculate the molar mass of unknown solute dissolved in the solution. And similarly, in the case of depression freezing point, And what is freezing point? The temperature at which the liquid will become solid. This is simple method. And if we confirm into scientific definition, what can we call? Here the temperature at which liquid state of the substance and the solid state of the substance are in equilibrium is called as what? Freezing point. Here always the freezing point of a substance. So here the freezing point of a substance, if you take here the freezing point is denoted by TF, and this TF of solution is less than the TF of what? Solid. Here therefore what can we say here? Delta TF is equals to TF naught minus TF. And same thing here also, the delta TF is proportional to what? Molality of the solution, and this is given by F into M, where this is called as cryoscopic constant or molar depression constant. Okay, and here also we can get it here as delta TF is proportional to M, and constant Kf into M, where Kf is called as what? Cryoscopic constant or molar depression constant or molar freezing point constant. So we know very well so from this equation we can calculate what the molar mass of unknown solute which is dissolved in the solution. Now coming to osmotic pressure. So osmotic pressure. First we should know osmosis. If you take pure solvent in a container and you insert a thistle funnel inverted position in which we can take solution in the thistle funnel. Here, and these two substances, that is pure solvent, this is solution. These are connected with the semi-permeable membrane, SPM. This is made up of some parchment paper or some membranes from the animals. So the role of semi-permeable membrane is it allows only the solvent particles. It allows only the solvent particles. It doesn't allow solute. Why? Because the size of solute is greater than that of solvent, and hence it allows only solvent. And what is osmosis? When a solution and a solvent is connected with a semi-permeable membrane, the passage of solvent into solution is called as osmosis. And if we keep some time, after some time what happens? The level is gradually increased when they are connected with a semi-permeable membrane. And what is osmotic pressure? The pressure required to prevent the osmosis is called as the osmotic pressure. The pressure required to stop, to prevent the osmosis is called as osmotic pressure. This is called, this is given by pi is equal to CRT. C means number of concentration, that is N by V RT, where N is equal to number of moles. So that is N2 by, that is what? W2 by M2 V RT. So that we can write it as pi V is equal to W2 by M2 into RT. From this equation, we can calculate the what's molar mass of unknown. And here we are applying the applications of osmosis in our daily life. So, for example, the flowers will be faded, or the flowers will be they will become not fresh by evening. So, if you keep them in the water, what happens to the process of osmosis? Again, they can become fresh. And similarly, in the pickle, in our hot season, our mothers and grandmothers prepare pickles. In that, initially the mango pickle, if you take, initially the size of the mango piece is more. After some time, it decreases. Why? Because the water which is present in the mango piece is coming into the solution. That's why the size of the mango piece which is present in the pickle will be decreased. That is due to osmosis. And nowadays we are getting a wonderful point, that is a reverse osmosis. Reverse osmosis. If you see the reverse osmosis, what are we doing here? We are connecting the solvent and solution with a semi-permeable membrane. But now what I did? I stopped the osmosis and I kept more pressure on this solution. By applying more pressure on the solution, the solvent particles which are present in the solution will come into, they travel into the solvent. So, which is opposite of the osmosis process. So, this is called as reverse osmosis. Nowadays, we are applying this principle in a water purifiers. We are releasing RO unit like that. That is reverse osmosis. So, that is what desalination of the seawater we are applying. This is a reverse osmosis in that one. And isotonic solutions.